Hello everyone, welcome back. In this video, we're going to talk about duration, and duration is a measure of interest rate risk for bonds. And we'll start chapter 20, the first few slides of chapter 20. And there's no mini exercise in this video, so let's get into it. Got the chapter 20 PowerPoint open. There's an in-class exercise, a spreadsheet on duration and immunization dated as of April 2nd. Let's open that up. So these next couple chapters about bond management, bond portfolio management. A big concern, among others, for bond portfolio managers is changes in interest rates, and we've had some big changes in interest rates recently. So a little bit of background on bonds, a couple terminology items. The face amount, the par amount, how much you get when a bond matures, that's usually $1,000 face amount is the increment of bonds. And then the coupon payment and the coupon rate are related, right? We can find out how much interest gets paid over the life of a bond. And then the bond matures, right? When its life ends. So algebraically, we can depict the price of a bond as the sum of the present values of the future cash flows that the bond generates, right? Where the discount rate is the bond's yield to maturity. Let's go over to the spreadsheet where we've got a nice little 4-year bond with an 8% coupon rate. Let's assume annual coupon payments for now. And you can see the cash flows associated with the bond. The bond is like an interest-only loan, right? Where we just pay interest payments for the first 3 years of the bond's life. And then in year 4, when the bond matures, one more coupon payment at year 4, and then the face amount that we receive at maturity. So the bond's price, we've got a discount rate here, the yield to maturity. The bond's price is the present value of all these cash flows. And we'll build out the duration of the bond, which let's show the equation for the Macaulay duration. We've got 3 duration measures in this course, all related. We'll get to them all in this chapter. And the Macaulay duration is the first. And you'll see it's a weighted average yield time to maturity, right? So time is the first term of the sum. And then each of this second term is a weight where the numerator is the present value of the cash flow at time t. Do you see that? See, cash flow at time t divided by 1 plus the discount rate raised to the t power, right? Present value of a given bond's cash flow as a fraction of the bond's price. Let's see how that looks. Let's build this out in Excel. And then Macaulay duration is a building block to a much more useful duration measure that we'll get to in the next video. But let's compute Macaulay duration as a good building block for interest rate risk management for bond portfolios. So first we find the present value of each of the cash flows associated with the bond, right? So there's 4 cash flows, and you can see cash flow 4 is the last coupon payment plus the face amount, right? So these are the CTs in the summation formula. Let's find the present value of those. The cash flow divided by 1 plus the discount rate, the yield to maturity, and I'll make that an absolute cell reference because we're going to copy and paste it over. And then we raise that to however long we have to wait for a given cash flow, right? Raised to the first power in this case. And so this first coupon payment is worth $75.12 today. If we copy and paste this formula over, you can spend some more time with it offline. Then we've got the present value of each of the 4 of the cash flows at each of the 4 years of the bond's life. So the sum of them, that's the bond's price. I'm getting $1,051.39, right? And so an equivalent way to find the bond's price using the PV function, where we've got the discount rate, the yield to maturity, the number of years until the bond matures. This is a 4-year bond. The coupon payment, $80 per period. The face value, the future value is $1,000. We should get the present value should be exactly equal to the sum of these, right? It's a negative number because present values come out as negative numbers in Excel. And I'll go ahead and negate this PV to make it a positive figure. Okay. All right, so the Macaulay duration function takes each cash flow's present value as a percentage of the price in it. So I've got a little space for us to do that here. So each cash flow's present value. Here's the first cash flow's present value, what it's worth today. And so it says what the Macaulay duration formula asks what percent of the bond's price, the bond's market value today, does this first cash flow represent? So if we take the present value of the cash flow divided by the bond's price, let me lock that cell reference, make it absolute, the denominator, because we're going to copy and paste this formula over. This first coupon payment represents 7.1% of the bond's price today. So that 7.1% figure represents, one term in this sum that I've highlighted. So let's copy and paste this over. We can see that the second coupon payment, 6.7% of the bond's price comes at year 2. 6.3% of the bond's value is delivered to the bond investor at year 3. We can see most of the bond's value is made up of the face amount and the last coupon payment. Those two things together make up about 80% of the bond's value. So the Macaulay duration is a weighted average maturity of the bond. So we take each period and multiply it by the percentage of the bond's total value that the investor receives in that period. Okay? If you think of Macaulay duration as a weighted average maturity, I think you should be in good shape. So let's compute the Macaulay duration sort of the long way. There's a function that we use in Excel, but if you can see how it's built, that's good for understanding, right? So let's walk through this summation formula and take each time until the bond matures times the percentage of the bond's value that occurs at each point in time and add them up. Right? So if you've got the Macaulay duration formula in front of you, you can look along. And so at time 1, right, T equals 1 times the percentage of the bond's price that occurs at that point in time, 7.1, right, that second term in the sum, plus at time 2, the investor receives, at time 2, the investor receives 6.7% of the bond's value, plus at time 3, the investor receives times 6.3%, and so on. And then at time 4, the investor receives, a bondholder receive about 80% of the bond's value. You can do the exact same thing that I just did using the sum product function or matrix operations, even better, whatever works best for you. But this Macaulay duration, the weighted average maturity of the bond is 3.6 years about. So if you look, right, given the fraction of the bond's price that occurs at various points in time, on average, right, we have to wait 3.589 years for all the bond's cash flows. It's a weighted average maturity. So in the next video, we'll see how that relates to a more tangible measure of interest rate risk, modified duration. Can't wait to talk about it. Thanks for tuning in.